Well, that's an interesting point. There's basically two different peaks for wind if you look at an average, but it really depends on where you are. Um, but basically, throughout the midday is kind of your best time, and in the evenings, like this, all the sailors come in because there's no winds and it dies off. In the afternoon, you get a good chunk, and in the morning, you get a good chunk too. So it's not as good of matching as solar. Solar, I mean, the sun's up, that's really time matched quite well. But wind is okay, I guess, if that's a suitable answer. Okay, so there's the link there, windatlas.ca. And when you go on here, this is a worksheet that you can all do. And when you come in to see any installer, you'll be really knowledgeable because you'll understand what you can get from your home. Basically, when you log on to, when you log on to here, you put your mouse over here and you find your spot and you click it. And when you click it, this next slide comes up. And this shows you, based on that area, that geographical center, how much wind you can expect. So what's important to see is that these are the average wind speeds throughout the different seasons. And so you can see, like I was saying, the lowest is in the summer months. And then here's the fall, it's slightly better than the spring, and the winter is better than that. So overall, you have a pretty strong wind pattern. The other thing that you can do is all this other stuff on the side is very technical, and it basically tries to assume how much wind you'll get. If you have a turbine that's up in the air, when during the day it will go, and during the month and during those seasons, how much power you'll get out of it. So it's not totally important, that stuff over there, and I'll show you some more meaningful stuff. So the next tab over is what's called roses. And this is a wind rose. And this kind of data, this is shared from the Wolf Island Wind Project, which is very helpful. Basically, this shows you the direction that your wind is coming. So the longer the red line, the more it comes from that direction. This is the annual wind rose, but there are wind roses by season too. So this will help you as well. Most people have a generally good idea where the wind is coming from. Their barbecue cover blew off that way, and that tends to work. All this stuff, like depending on how technical you want to get to, you can download all this data and really go to town and analyze this. I'm trying to keep it at a high level, but it depends on what you want to get into. This is a histogram or a plot of how much power you'll get at your site. So, like I said, that those wind turbines, when their capacity is stated, you're going to get a whole bunch of different wind speeds. You're going to get a lot of wind speeds in the small, on the low end, and then it will taper out here as well. And so this is how they come up with a better approximation of how much power you'll actually get from your turbine. What I think is pretty neat in here is this is where you can actually put in your specific turbine formula. So if you're working with your installer and they provide some ideas to you, well, you can go home and do this homework yourself, or they can help you with that. And basically, all those turbines, like the ones I showed you last week, will have a spec sheet, and it will say things like the max power output of the turbine, and the cut-in speed, and the rated wind speed. You enter that, and you say go, and it will give you actual amounts of power that you can expect from that. So this circle kind of shifted, but if you're expected to get 3.9 megawatt hours per year out of that turbine, and you match it up with your loads, then you can understand how much that will give you. Does that make sense, the megawatt hours? Do people know what that is? That's 1,000 kilowatt hours. Does anybody have any questions about that? No? It's okay. Lots of confused faces. Maybe it's late in the night. I don't know. So just how you would do that with a turbine. Say you found this amazing turbine and you want to understand what it will do for you. I went through this a bit last week, but this is probably the most misunderstood part about small wind, I would say. Every turbine has a power output graph that goes with wind speeds. The faster it goes, the more power it will generate. Basically, the way that these turbines are rated is totally confusing. So I totally feel sympathetic for everybody in here. When it says SkyStream 3.7, you might think that that refers to some amount of power, but it has nothing to do with that at all. This turbine is actually rated at is 2.4 kilowatts. Okay, so that's the first disconnect. So how does that 2.4 kilowatts come about? Well, this is at the peak of it up here, but the rated wind speed is at 29 miles per hour. So you're not really going to get that every day around here. The other factor to think about is the cut-in wind speed. So this is at 8 miles an hour. So until you get to 8 miles an hour, the wind turbine won't generate anything at all. The other thing to really think about is the survival wind speed, which is 140 miles an hour. Now that's basically what that means is that it's designed to slow down the blades in winds that fast. It has nothing to do with is your tower going to blow over or is it going to rip apart or things like that, which gets into our next conversation that we need to have about the engineering in the tower and the foundation. But those are sort of the key specs. So when you're looking over all the glossy literature on all these turbines, those are the things that you should focus on. The next biggest thing I'd say people want to know about is how to position it on their property. So a lot of this stuff, or pretty much all of this that I'm going to talk about tonight, is on the horizontal axis turbines. So this is what you're most familiar with, where the blades, there's a shaft and the blades rotate on that shaft. That's in a horizontal plane. Vertical ones are the opposite, 90 degrees to that. Horizontal ones, basically they need to be up and into nice clean air, nice clean wind. And what I mean by that is, if you have a home and if you were able to see the wind as it flows over the home, it would catch on things and tumble off the other side. And basically the wind's in all directions and would really whip that turbine around, making it very hard on the machine, but also you're not going to get as much power out of that wind as you would if it were higher. So when you're up higher, it's at what's called a laminar flow, or really clean air, and it flows in a nice smooth direction and will just spin that turbine constantly. So there's less wear and tear and it has more kind of punch to it as well. And this is what I was talking about with height. So this graph is trying to show if you take the same turbine, same head, and you have it at 33 feet, and say you take it up to a 60-foot tower, well, you've increased its power by 41%, roughly. So a lot of people say, well, should I get a bigger turbine? And I say, well, how high can you go first? Because that's your biggest bang for your buck. You make your foundation a bit stronger and you have a bigger pole, but that's how you get the most out of it.